So Newton's first law states that an object at rest will stay at rest unless acted upon by a total net force. So right now, the forces acting on the pool bar are equivalent to about 0, right? The gravity and the normal are going to be equal, and therefore the ball is not moving as it's not being acted upon by a total force. However, as soon as the ball is hit, it experiences a force to the left, which is the pool cue hitting it, and then a small to the right, which is the friction. Same with this ball. It experiences a normal, and then in a similar fashion to the first ball, it gets hit to the left by the other ball. So now we can move on to Newton's second law. So Newton's second law states that force is equal to the mass of an object multiplied by its acceleration. And we can prove this by hitting the cue ball 3 different times with a different amount of force each time. So first we hit the cue ball as sort of a control test, not too much force, not too little force. The force is sort of in the middle, and the mass is going to stay constant throughout all 3 experiments. So we're going to be able to prove this by seeing how quickly the ball accelerates the moment it's hit. So in the first time, it takes about 2.2 seconds to get to the end, implying that the acceleration wasn't very high. However, the force also wasn't super high. With an increased force, however, we find that the immediate acceleration is very great, and with a decreased force, we find that the immediate acceleration for that moment is pretty low, causing it to take a substantially longer time to reach the end. So now for Newton's third law, every action has an equal and opposite reaction. So immediately, the cue ball is hit into the 6 ball. So now, when the cue ball hits the 6 ball, it's going to apply a force of its mass multiplied by its acceleration. However, the 6 ball is going to apply a force back onto the cue ball, which is equal to that of which the cue ball hit the 6 ball, which is in turn going to slow the cue ball down because the force acting on it is negative or in a leftwards direction, whereas the force acting on the 6 ball is in the rightwards, or in this case, positive direction. As you can tell, the cue ball slows down. Now, here, sort of just another angle, but when the cue ball is going to hit the 4 ball, as soon as it hits it, it experiences a force back upon itself. And as you can see, its speed slows down substantially because the force acting upon it is negative, and therefore its acceleration is going to be negative. And, well, thanks for listening. All the laws apply very heavily to a lot of games like pool, snooker, and other sort of table-based games, and these are just a couple of the ways that they interact. Thanks for listening.